Now we're going to test whether the regression is significant or not. But before we get to the test itself, let's look at the assumption needed for the test. Now our regression model is this: beta sub 0 plus beta sub 1 x plus the error term epsilon. Now the assumptions are about the error term. So if the model is true, then the error term is a random variable with the mean or the expected value of the epsilon being equal to 0. So the error has a mean of 0 and it fluctuates on the positive or the negative side. And that's the first assumption. The second assumption is that the variance of the epsilon, the error term, is denoted by sigma squared, and it is the same no matter what the x value is. If x changes, the variance doesn't change. The third assumption is that the error terms are independent. Then finally, the error terms are normally distributed. And if error term is normally distributed, then y is normally distributed also, because this is not, this part of the model is not a random variable. So if epsilon follows normal distribution, y will also follow normal distribution. Now these assumptions can be seen in a kind of a graph format. So here is figure 14.6. So this means if this is the x value and if these are the y, then the mean of y, which is beta sub 0 y-intercept plus beta sub 1 x, fall on a straight line. So that is our model. Expected value of y is beta sub 0 plus beta sub 1 x. Now the actual y value is that mean plus or minus some error term. Okay, error can be negative or positive. So the actual y value will follow that mean plus or minus an error term. And the error term follows normal distribution. So here is the normal distribution. So this is a graph that describes all the four assumptions. And you see that the variants are all the same no matter what the x value is. Now, given these assumptions, then we can test for significance of the regression. The regression is said to be significant if the slope is not equal to 0. So let's go back here. If the slope is 0, so that means it is just parallel to x, so y value doesn't change at all. It is just beta sub 0 plus or minus an error term. So the x doesn't matter if beta sub 1 is 0. So if the slope is 0, then the regression is not significant. We don't have to do anything with regression. So if the regression is significant, then beta sub 1 must be not equal to 0. So that is what we want to test. And you can do this test using a t-test or an f-test. So let's first look at the t-test. The t-test needs an estimate of standard error for b sub 1. So we start with an estimate for the common variance, which is SSE over n minus 2. That is our mean square error. Then you take a square root of that, and that gives us the standard error estimate. And you take that standard error estimate and divide by this value, then you get standard error of b sub 1. Once you have the standard error of b sub 1, then you can compute a test statistic t by dividing b sub 1 by the standard error of b sub 1, and then compute the p-value using the t dot dis dot 2t function. But it turns out that when you run the data analysis regression command, all of this information is automatically computed and given to us as the results. Now you can also develop a confidence interval for beta sub 1 by taking b sub 1, and then this is our margin of error, the t table value times s sub b sub 1, which is right here. And once again, your data analysis regression output gives us the confidence interval. If you want to do the f-test, first we have to compute the mean square error MSR. That is SSR divided by the degrees of freedom for regression, which is the number of independent variables, which in our case in simple regression is equal to 1. Then the test statistic is MSR divided by MSC. That's our F value, and we can compute the p-value using f dot dis dot rt, and this p-value is also given in the results of the regression output from the data analysis. Now there is one caveat that even if the regression is significant, this doesn't mean that we've established a cause and effect relationship. The best we can do is to say that there is an association between the x and y variables. Now we will look at an Excel example.